welcome to today's deep dive. We have a really fascinating stack of documentation to look at today.
Yeah, it's incredibly detailed.
Right. Specifically, we are examining the HumAIne project's AI augmented interface.
Or AAI for short.
Exactly, the AAI. And alongside that, we are peeling back the curtain on its accompanying developer ReADE file, which was put together by Immersive Lives.
Which is great because it gives us the complete picture. You know, we get the conceptual framework of the software and then the actual unvarnished instruction manual for deploying it onto a physical breathing factory floor.
Yeah, the real nitty-gritty. So our mission today is to unpack how extended reality, or XR, combined with artificial intelligence, is completely revolutionizing complex manufacturing.
It really is a revolution.
It is. We are exploring how this technology shifts human operators from being just, passive monitors of a system into active, empowered directors of AI systems.
Right.
And we're going to look at exactly what it takes to build this architecture from a developer's perspective.
And, if you are listening to this right now and thinking, well, I don't work anywhere near a factory floor, why does this matter?
Yeah, fair question.
You should still treat this documentation as a blueprint, because this goes far beyond manufacturing.
Absolutely.
What we are looking at is a real-world functional framework for how humans and AI will collaborate, communicate, and evaluate each other in absolutely any high-stakes environment in the future.
Like logistics or healthcare.
Exactly. Or managing an energy grid. The principles are the same.
Okay, let's unpack this. Imagine walking into your workplace with a heads-up display, almost like Iron Man.
Oh, I love that comparison.
Right. But instead of fighting supervillains, you have these spatial menus just floating in the air, allowing you to command complex factory machinery and instantly see what an AI is thinking.
Yeah.
That is the exact reality this XR technology creates.
And the documentation paints a really vivid picture of this experience. The AAI provides interactive 3D visualizations that literally overlay the real world.
It's augmented reality in the truest sense.
Right. You are wearing an XR headset, looking at the physical machines right in front of you, but superimposed over them is this highly reactive digital layer of data and control.
So before we get into the code, we need to understand what the human operator actually sees and does inside this mixed reality scenario. Like, what is the experience of interacting with that digital layer?
Well, the sources break this down into distinct visual interfaces, starting with machine view.
Okay.
This displays those spatial menus right next to the physical machines. It gives the operator key metrics, performance status. But the most crucial feature here is that it displays task bids.
Task bids.
Yeah, it actually shows the auction winner for specific machine tasks.
Wait, so the AI is essentially running an invisible microsecond auction to decide which machine should do its job.
Exactly.
And then it's projecting the results of that auction into the physical space so the human operator can see who won.
What's fascinating here is that by displaying those task bids and auction winners, the system is actively providing AI explainability.
Showing its work.
Yes. It isn't just silently rerouting materials and saying, machine B is now doing task X. It is showing its work based on the parameters it was given.
Which is huge for trust.
It's the foundational step in building human-machine trust. I mean, if an operator doesn't understand the logic behind an AI's decision, they will override it or ignore it when a critical situation arises.
Right, because pulling back the curtain builds that confidence. And zooming out from the individual machines, the documentation also describes something called the dashboard view.
Yeah, the dashboard view is critical.
It acts as a centralized panel for the operator, featuring a performance panel that tracks big picture metrics like energy consumption, lateness, and throughput.
All the heavy hitters.
Yeah, and next to that is a timeline panel, giving historical and real-time views of all the manufacturing activities.
So the interface gives you the context of what just happened, what is happening right this second, and the trajectory where the factory is heading.
Which is a lot of power.
It is. But the component that truly defines the philosophy of the HumAIne project is what they call the objectives panel.
Right. The documentation specifically highlights this under the umbrella of human empowerment.
Yes, human empowerment, which is such an important term here.
So the AI is not a dictator. The human operator holds the leash. Like if a massive rush order comes in, the human can look at the objectives panel, reach out, and literally dial up the weight of the speed objective while dialing down the energy-saving objective.
Yeah, Exactly.
It's like a mixing board for AI behavior.
That's a great way to put it. You are adjusting the fundamental weights of the optimization objectives in real time.
While the AI keeps running the floor.
Right. The AI continues to do the complex math, and it continues running those microsecond auctions to assign tasks, but the operator is setting the ultimate priorities.
You're guiding it.
You are giving the AI its North Star, fine-tuning production goals and resource allocation based on, well, human context that the machine might not have.
So you aren't just watching a progress bar fill up.
Mm-hmm.
You are conducting the orchestra.
Precisely.
But designing an interface that lets a human conduct an AI orchestra is really only half the battle. A truly advanced system shouldn't just take orders, right? It should learn from how the operator behaves while giving those orders.
Which brings us to the architecture of the software itself.
Yes.
The documentation outlines a specific framework for visualizing the software architecture, showing a massive evolution in how this system was designed to function.
Because it used to be a lot simpler.
Right. It moved away from what the docs call a purely operational optimization loop.
Right. In that older model, it was basically a one-way street. The operator talks to the AII, the AII talks to the digital or agent-based systems, and the data comes back.
It was functional, sure.
But it wasn't learning anything about the human using it.
Exactly. The absolute necessity for the Humaine project was transitioning to a feedback-driven system.
And how did they do that?
They achieved this by integrating two massive components into the architecture, the benchmarking suite and the evaluation component.
Right, the benchmarking suite's job is the systematic monitoring of the human operator's interaction with the system. It quietly sits in the background, collecting user data.
Very quietly.
The docs specifically note it is tracking execution times and errors in specific tasks.
Yeah, so it monitors how long it takes an operator to make a decision when those spatial menus pop up.
Oh, wow.
It notes if an operator accidentally selects the wrong optimization weight on the mixing board and has to correct themselves.
So it's watching all the micro-interactions.
Right. It uses all of this behavioral data to evaluate the usability of the interface, and then uses those insights to refine both the AI itself and the underlying optimization pipeline.
Here's where it gets really interesting. This evolution is the difference between a car that just turns when you pull the steering wheel and a smart car that realizes you always take a specific route to work, so it starts optimizing its battery for that exact trip.
That's a perfect analogy.
It's evaluating us while we evaluate it.
If we connect this to the bigger picture, this shift is vital because it elevates the AAI into a monitorable and a valuable system.
Which is pretty rare for enterprise software.
It really is. Think about the traditional approach to enterprise factory software. It gets deployed, and if the interface is clunky or unintuitive, the workers simply suffer through it.
Yeah, they just deal with it.
Their efficiency drops, or they find dangerous workarounds because the tool is poorly designed.
The burden of adapting is entirely on the human.
Exactly. But by integrating the benchmarking suite directly into the core architecture, the ultimate goal expands beyond just maximizing machine efficiency.
Right.
It becomes about continuously improving the quality of the AAI in supporting the human. It formally acknowledges that the human's cognitive load is a critical system metric that needs optimizing just as much as a machine's power consumption.
The human's cognitive load is a system metric that completely reframes the relationship.
It really does.
But, okay, capturing all of this granular human feedback, the menu clicks, the execution times, the error rates, and securely piping it into the factory's brain while also pulling real-time data out of the machines. That requires some incredibly robust internal plumbing.
Oh, absolutely. The component layer of the AI architecture is where that heavy lifting happens.
Because things had to change there, too.
Yes, the internal modules underwent a major technical shift to handle this new feedback-driven reality.
Right.
The system originally relied on an API request handler, but the documentation details an evolution into what is now called the AAS service module.
Okay, the AS service module.
Yeah. This new module is what actually facilitates the interaction between the XR application and external systems, like the factory's digital twins.
And the documentation emphasizes that this change reinforces strict alignment with the Asset Administration Shell Standard, or AAS.
Right.
Okay, Asset Administration Shell Standard sounds incredibly dense.
It is a bit of a mouthful.
Why go through the trouble of evolving the API request handler just for this? I mean, we have standard APIs that can stream 4K video flawlessly to a phone or handle millions of financial transactions a second. Why couldn't they just use run-of-the-mill internet architecture to talk to these digital twins?
Well, you have to consider the physical reality of the environment. When you are dealing with standard internet architecture, a dropped packet or a half-second latency spike usually just means a web page takes slightly longer to load or your video buffers for a moment.
Right, mildly annoying, but fine.
Exactly. But in a heavy manufacturing environment, you have an XR headset trying to render 3D spatial menus in a worker's field of vision in real time.
Yeah.
You have the benchmarking suite constantly streaming behavioral metrics. And most importantly, you have robotic arms, conveyor systems, and temperature sensors, all represented by their digital twins moving physical mass at high speeds.
So the stakes for a half-second delay are a lot higher than a buffering video.
Astronomically higher. You cannot rely on fragmented API structures, where one robotics manufacturer formats their data slightly differently than the XR headset expects, or where latency is unpredictable.
Right, that sounds like a recipe for disaster.
It is. You need a universal industrial-grade standard. The asset administration shell acts as the ultimate standardized digital representation of every single asset in the factory.
So it forces everything onto the same page.
Precisely. By forcing the AAI to communicate strictly through the AS service module, the developers ensure that the digital twins, the real-world machines, and the augmented reality interface remain perfectly synchronized without any translation errors or dangerous lag.
It's like forcing everyone in a loud, chaotic, high-stakes room to speak exactly the same highly structured language. There is zero room for misinterpretation or hesitation.
Exactly. It removes the friction from the data pipeline. When you are blending real-time physical automation with a digital overlay that a human is using to make split-second decisions, friction is the enemy.
Okay, so the architecture is clearly brilliant on paper. You have the human in control via the objectives panel, the system learning from the human via the benchmarking suite, and a rock-solid data standard keeping the digital twins synced.
It's a very elegant theory.
It is a flawless theory, but theory often shatters when it hits the reality of software deployment.
Oh, always.
Looking at the readme file provided by Immersive Lives, actually building this humane manufacturing demonstrator requires intense developer discipline.
The readme is the instruction manual where developers hit the wall of enterprise constraints.
Yeah.
There are strict implementation hurdles outlined here that dictate exactly how the system must be constructed.
And the first hurdle that jumps out is the core software dependency. Developers are explicitly instructed that they must use a very specific Unity 6000 series build.
Unity version 6000.6 F2, to be exact.
Right. And the documentation warns that attempting to use any other version of the engine may cause severe compatibility issues.
In the world of Unity development, locking a project to a specific minor build version usually indicates highly customized, fragile integrations happening under the hood.
Because developers usually want to upgrade, right?
Oh, yeah. Developers generally prefer to keep their engines updated to leverage new features or security patches. But here, the entire augmented reality interface, the physics of the spatial menus, the rendering pipelines for the machine views is inextricably tied to the exact math of that specific Unity release.
So you cannot casually upgrade your environment?
Not at all.
And that locked dependency is just the beginning. The real architectural complexity comes with how the software talks to the outside world. The system doesn't just ping a single server to get its data.
No, it's way more complex than that.
The readme outlines the necessity of balancing two completely segregated back-end environments.
Which perfectly mirrors the dual nature of what the entire Humane project is trying to achieve. You have one side focusing on the human and the other side focusing on the machinery.
Right, so the first backend is the HMI, or evaluation environment. This handles all the logging, the user identification, and the survey delivery flowing from the benchmarking suite.
Yes.
The readme notes this must point to a dedicated external evaluation domain. I think it defaults to benchmark.humane-horizon.u.
That's right.
So this entire server is dedicated solely to being the brain that studies the human.
Completely segregated from that evaluation environment is the second backend, the DFKI, or production server.
Okay, and what does the DFKI server do?
This server handles the actual factory mechanics, the optimization objectives, the task bids, the machine metrics.
Okay.
This connection is configured directly within the Unity scene components, specifically on the HMI Bridge Manager component.
So developers have to set the base URL for the production API there.
Yes, and there's a specific toggle mentioned to use server config to fetch runtime configurations directly from the server.
Right, and by enabling that, the app pulls live factory data like safety boundaries and state iterations straight into the headset.
Exactly. And the documentation also specifies that the evaluation flow requires developers to inject a bespoke plugin called HMI-evaluation via a Git URL in the package manager,
Wow.
which just further highlights how custom-built the human monitoring aspect of the software really is.
So what does this all mean for a developer trying to build this? It means precision and separation are everything. You're balancing two distinct brains, the evaluation backend studying the human's cognitive load, and the production server actually running the robotic arms. It's a delicate technical tightrope.
This raises an important question, though. When developers see constraints like locked engine versions or highly segregated server environments in a readm file, it's easy to view them as annoying corporate red tape.
Sure, it seems like a hassle.
But they are defensive architecture. These strict boundaries are the guardrails necessary to ensure a mixed reality system doesn't accidentally crash a real-world factory.
It is the ultimate separation of concerns on an industrial scale.
You absolutely want the system evaluating the user's survey responses to be on a completely different server than the system calculating the safety boundaries of a robotic arm.
That makes total sense.
If the evaluation server crashes because it's overloaded with eye-tracking log files, the production server remains untouched, and the factory keeps running safely.
Wow. We have covered incredible ground today exploring the Humaine project's documentation. To quickly synthesize this journey, we started with the AAI's Iron Man-style XR interface, visualizing how spatial menus bring complex task bids directly into the physical world.
Yeah.
We saw how the objectives panel acts as a real-time mixing board, empowering humans to dictate the AI's priorities.
And then we examined the architectural leap from a one-way command loop to a feedback-driven system.
Right.
By integrating the benchmarking suite, the software constantly evaluates execution times and errors, treating the human operator's cognitive load as a vital metric to be optimized.
We dug into the AAS service module backbone, which utilizes the asset administration shell standard to ensure all the data flows seamlessly between the headset and the digital twins without translation errors.
Essential for safety.
And finally, we decoded the readme file, revealing the strict dual backend Unity environment required to safely deploy this demonstrator.
The biggest takeaway from synthesizing all of this source material is a profound philosophical shift.
How so?
For years, the dominant narrative around AI in manufacturing has been about automation eventually replacing the human worker.
Right, the robots taking our jobs.
Exactly. But this documentation proves a completely different trajectory. The future of industrial AI isn't about replacing the operator. It is about highly augmenting them.
Yeah.
It places the human firmly at the center of the decision-making process, armed with more context, visibility, and control than ever before.
It is an incredibly optimistic view of the future of work. But I do want to leave you with a final thought to mull over, building on the mechanics we've discussed today. The benchmarking suite relies on monitoring our execution times and our errors to relentlessly optimize workflows.
Right.
The AAI is designed to be as helpful and frictionless as possible. But as this XR system gets better and better at anticipating our needs and feeding us exactly what to do via those spatial menus floating in our vision, do we run the risk of operators relying too much on the digital overlay? If the system is always calculating the optimal move and highlighting it for us, do we potentially lose our raw physical intuition for the factory floor? Just something to think about the next time you blindly follow your GPS instead of looking at the road. Thank you for joining us on this deep dive. Hopefully you feel a little more prepared for the day those spatial menus show up in your own workplace.